So I was feeling rather upset with the fact that I couldn't fit what I wanted to write at the bottom of the page. So I wrote it. Sine phi equals b by h, as I mentioned in my previous video. And I have defined b by h as cos theta. So sine phi should be equal to cos theta. And on the other hand, I've again said that phi equals 90 minus theta. So sine 90 minus theta is cos theta. If I use the reverse logic, I should be able to say that sine theta is cos 90 minus theta. So you see, that is what I have written here when I have said sine theta degree is cos 90 minus theta degree. Again, here I have considered the degrees. You can again consider the radians. So in that case, what you would have is cos of pi by 2 minus theta is sine theta, or sine of pi by 2 minus theta is cos theta. So since 90 degree equals pi by 2, you just essentially switch between 90 and pi by 2. So that's a very interesting concept, and you will understand why that can help us. So let's go back to the table, the original table that we have, and let's yes. So the first line, this first line is a line that we'll have to remember. There are easy ways to remember it, but this one we'll have to remember. So let's start with the first row. So you see sine 0 degree or sine 0 radian is 0. Sine 30 degree or sine pi by 6 radian is half. Sine 45 degree or sine pi by 4 radian is 1 by root 2. Sine 60 degree or sine pi by 3 radian is root 3 by 2. Sine 90 degree or finally sine pi by 2 radian is 1. One thing, if you notice, is half is obviously, most obviously, greater than 0. We know that root 2 is less than 2, because if you square root something, of course it will decrease in value, it will decrease in magnitude. So root 2 is less than 2. That is, we have in the denominator we have a number which is smaller than the preceding one. So if 2 is greater than 1 by root, if 2 is greater than root 2, then half should be less than 1 by root 2. So half is greater than 0. 1 by root 2 is greater than half. Needless to say, it's very obvious that root 3 by 2 is also greater than 1 by root 2. Finally, 1 is the greatest of them. So you see, as the value of the angle keeps on increasing, the sign of that also increases up till 90 degree. In further discussions, you will notice that after that it keeps on falling. So we have something called a sine curve, which is a swinging curve. So it goes up, goes down, and again goes up, and it proceeds in that way. But at least in the concerned range of 0 degree to 90 degree or 0 radian to pi by 2 radian, as the angle increases, as the magnitude of the angle increases, so does the sine value of that. So if I consider sine 30 degree and sine 60 degree, you can obviously say sine of 60 degree will be greater than sine of 30 degree, at least in this range 0 to 90 degree. So that's an interesting fact that we need to remember. Another thing that we need to remember that is, it's an interesting point to notice. When we say sine 0 degree, we essentially say that this theta, the angle under consideration, is 0. So that means the angle enclosed by the hypotenuse and the base is 0. Now, let me just remove this arrow as well. What I essentially mean when I say theta is 0 is this line AC moves down and it coincides with BC. So this angle essentially becomes a straight line like this, and AB, the perpendicular, virtually tends to 0. It's practically inexistent, and BC equals the BC line equals AC. So BC and AC coincide with each other. When we say that sine theta equals 0. So when we define, or when we say that theta is 0, then the perpendicular, as I've mentioned before, the perpendicular ceases to exist. So obviously, if the perpendicular ceases to exist, the length of perpendicular makes no sense. That's 0. That's essentially 0. So sine theta will be 0 by whatever hypotenuse value is. Sine theta will be 0. So that is why we say sine 0 degree is 0. That's one end of the first row discussed. So that's how we explain one end of this row. Now let's move on to the other end of this row. We can also talk about the middle, that I'll do at the after this. So let's tackle the other end. So we talk theta equals 90 degree or pi by 2 radian. So this theta value, if this becomes 90 degree, first of all, it's practically a limiting sense, because we know that the sum of the three angles of a triangle is 180 degree, and we have already fixed the fact that angle ABC, angle B, is a right angle. So if we say that angle C, that is angle ACB, is also 90 degree, then that essentially means angle BAC is 0. So that doesn't make a lot of sense. Similar to the fact that the previous one itself also cannot make a lot of sense, because you can't have one angle of a triangle 0 degree. It won't be a triangle. Both ends of the both the ends of the row are essentially limiting concepts. So that's a very abstract way of thinking. So even though that's a little abstract, let's still imagine a way out, and imagine that theta is 90 degree. So that means BC and AC are perpendicular to each other. We can't change BC, but as I mentioned before, this angle AC can pivot around C. So that essentially means that if I remove this arrow, this time the side AC will move on the opposite direction. So this time it will move this way. It will pivot around C. So A will move like this, the line itself, and it will become some sort of this. So let me just draw it properly and use a straight line. So this time AC will be a line of this source that will be parallel to AB, and it will also be perpendicular to BC. So that's how we'll have the new AC line. Now going back to the definition, sine of theta will be sine of 90 degree, which is perpendicular by hypotenuse, and we can only have a triangle if AB and so-called AC, some AC, this should also be AC, and these two lines should meet at some point, which will actually meet at a point infinity. So AB and AC are essentially two infinite line segments. Not even line segments, they are two essentially infinite lines. So we can, in an abstract way, say that both of them are equal in length because they are both infinite in length. So perpendicular and hypotenuse have the same length. That means the numerator and the denominator are the same. So we can, again, in a limiting sense, say that sine theta is 1. So that is why we can say sine 90 degree is 1. Again, you can try it out as a homework. If you say 45 degree is the theta, then you can try it out at home. You will see if this angle is 45 degree, then AB will be equal to BC. That is, we'll have AB equals BC, and we know the Pythagorean theorem, which says that AB square plus BC square equal to AC square, no matter what the lengths of the triangle are. So what I want you to do is assume a particular length of AB. So assume AB equal to BC equal to A, and that way you'll be able to find the length of AC through the Pythagoras theorem. And I want you to put those values in the P by H form. You will see the ratio will come out to be 1 by root 2. So you will have sine theta when theta is 45 degree. You will have sine 45 degree as 1 by root 2. So you can try that out as a homework. If not, write them down in the comment section below. I will surely explain the concept in a future video. So that's how you can get the first row. You can explain, in fact, you can explain 3 of the 5 values of the first row.